Okay, in this example, we're going to be graphing a sine function with a certain number of transformations. Let's start. We notice that we have a few things going on here. Here at the front, we have a vertical stretch and a reflection in the x-axis. Over here, this 6, which we will be factoring out, is going to be a horizontal compression. We're going to have a phase shift as well, not 180, as you will see, but 180 divided by 6, which is 30. And then over here we have a vertical shift up 2 units. So before we begin, let's write this function in a form that is recognizable. And by the way, we are doing this over the interval of 0 to 180. I just say recognizable. All I mean by that is the b value is factored out. So I can write this as -2 sine, and the 6, which is my b value, I'm going to factor it out from the argument of the sine function. That'll give me 30, close bracket, and then I get a +2 over here. Okay, so from this we can see all our important values, namely we have a is equal to -2, the b value is 6, the h value is 30, and the k value is 2. Okay, going back to our graph here. So for sine, remember the original goes something like this. Not quite, something like this. And our new one is going to be stretched and transformed accordingly. So how shall we start? Well, I'm going to begin by doing my table of values. I find this is the easiest way. Again, as you get better, there's actually even, you get more intuitive. You build an intuition on how to graph these without doing a table of values. You can just kind of eyeball it. So we have our x, and we have our y. Remember, our base table is going to be 0, 0, 91, 180, 0, 270, -1, 360, and 0. And I'll just shrink this, put it over to the side. And the transformation we're going to be using is x comma y will be mapped to, I need a bit more space here, it'll be 1 over b x minus h comma ay plus k. And our b value is 6, so we're going to have 1 over 6x minus -30, so it'll be plus 30, comma -2 y plus 2. Okay, let's also shrink this because we don't need it really. And this guy, this is what we're going to be using. Let me put the xy in front. Okay, so what are the points that we're going to be pulling out? Well, it's everything that's indicated over here for my x's and over here for my y's. So my first point is going to be 0, 0, and that will map to, I'll do it over here at the side, so 0, 0, that's going to go to the point 30, 2. The point 90, 1 is going to go to, let's see, 90 divided by 6 is 15 plus 30 will go to 45, -2, 0. The point 180, 0 will go to 180 divided by 6 is 30. We'll go to 60, comma 2. The point 270, comma -1. We'll go to the point 75, comma, that'll be 2, 4. And finally the point 360, comma 0 is going to go to the point 90, comma, what do we have here? 0 will go to 2. Okay, so we have our points. I'm going to plot them using a different color. Let's use the blue here. So 32 will be over here. 45, 0 will be roughly over here. 62 will be here. 75, 4 will be over here. And 90, comma 2 will be over here. So I think you can see the sinusoidal pattern that will be, it's determined by these points. We will have a line coming down, going up, and coming down again. And remember, we are sketching this over the interval from 0 to 180. So I'm going to take this, copy it, paste it, and repeat it here. And I'm going to repeat it again, even though I'm not going to use this entire part. There we go. Actually, you know what? Instead of doing that, I will just continue my line. And I'm ending here at 180. And similarly, and everything before 30, that's going to go back up like this. No, bit of a mistake. It's going to go up like this and then down. There we go. So there's our interval from 0 to 180. And now we can answer some questions in terms of the amplitude, period range, sinusoidal axis, and phase shift. So what do we have here? The amplitude. Well, that's just the distance from the middle, right here, to the top or bottom. So that's going to be 2. So let's say amp. I think I'll do a slightly thicker color. Amplitude is equal to 2. The period, well, that's pretty clear. If we start over here and end over here, that's one cycle. That goes from 30 to 90, so that's going to be 60 degrees. The range, I'll do it down here. Well, that's all y values, such that 0 is less than or equal to y, because that's the lowest point down here, and the highest point is going to be less than or equal to 4. So there's our range, sinusoidal axis, and that is the line down the middle, this guy over here, which in this case is going to be y equals 2. And finally, the phase shift. So remember, sine initially starts at the middle and goes up. So it starts over here, goes up, and comes down. I mean, the thing is, the phase shift in this case hasn't really changed the way the graph looks in terms of, I guess, the phase component. It's probably easier to just read it off the equation here, which is a phase shift of 30 degrees to the right. So phase shift is 30 degrees right. And there's our graph of sine transformed.